Have you ever looked at a map of the world and wondered what lies beneath the vast blue oceans? It's a place of incredible pressure and total darkness. A world so different from our own, it might as well be another planet. For centuries, we could only guess what was down there. But today, with incredible technology, we are finally pulling back the curtain. We are exploring a realm filled with geological wonders and bizarre creatures. Deep beneath the waves, near the island of New Guinea, scientists have found something truly spectacular. It's a place that challenges everything we thought we knew about where life can exist. It's called the kunlun-hydrothermal-field, and it is absolutely massive. Imagine a city of underwater chimneys, all billowing with superheated water from inside the earth. This isn't just a small collection of vents. It's a sprawling, dynamic system that stretches for miles across the seafloor. Before we can truly appreciate the magnificence of the Kunlun field, we need to understand what we're even looking at. So, what exactly is a hydrothermal vent? Think of them as geysers on the ocean floor. It all starts with the Earth's tectonic plates, massive puzzle-like pieces of crust that shift. At boundaries where plates pull apart, seawater seeps down into cracks in the ocean floor. Water travels deep into the crust toward a magma chamber. The chemistry begins as cold seawater gets superheated, sometimes over 400 degrees Celsius. That's over 750 degrees Fahrenheit. The water becomes a hot, acidic fluid that reacts with surrounding rock. It dissolves minerals from the crust. It picks up sulfur, it picks up iron, it picks up zinc, it picks up copper. The mineral-rich fluid becomes less dense and rises. It shoots back up toward the seafloor with tremendous force. When it erupts into near-freezing seawater, dissolved minerals instantly precipitate into solids. This rapid precipitation builds the iconic vent structures. You might have heard them called black smokers. You might have heard them called white smokers. The color depends on the minerals they carry. Mineral deposits accumulate into towering chimney-like structures. These vents are oases of life in the deep sea desert. So how do you find something like the Kunlun field, hidden thousands of meters below the ocean's surface? You don't just stumble upon it. Its discovery was the result of meticulous planning, cutting-edge technology, scientific detective work. For years, oceanographers had been studying tectonic activity near Papua New Guinea, complex geology where multiple tectonic plates grind against each other. The search began with ships mapping the seafloor with advanced sonar. Sonar sends sound waves down and measures echoes. The data becomes detailed topographical maps. While scanning, researchers noticed anomalies in the water column, plumes with different temperatures and chemistry. Those plumes were the breadcrumbs leading to a vent field. The real moment of discovery came with the deployment of a remotely operated vehicle, or ROV. Think of an ROV as a sophisticated underwater robot tethered to the ship by a long cable. It's equipped with high-definition cameras, powerful lights, robotic arms, and a suite of sensors to measure the environment. As the ROV descended into the crushing darkness, its lights cut through the gloom, and the team watched with bated breath from the control room on the ship above. Every hydrothermal field is unique with its own chemical signature. But Kunlun has a secret ingredient, an incredible amount of hydrogen gas. While many vents release compounds like hydrogen sulfide, the sheer volume of pure hydrogen bubbling up from Kunlun's vents is extraordinary. This isn't just a minor chemical quirk, it's a game changer. Hydrogen is one of the most basic and potent fuel sources for life, and its abundance here opens up new metabolic possibilities for deep-sea organisms. Where is all this hydrogen coming from? The answer lies deep within the Earth's mantle: serpentinization. Seawater seeps into fractures and reacts with mantle rocks, especially minerals like olivine. That chemical reaction alters the rock and releases large amounts of hydrogen, methane, and other simple organic compounds. The large hydrogen signal suggests very deep fractures reaching the mantle. It's a direct link between the deep ocean and the deeper Earth. For origin of life scientists, this is thrilling. Beyond its sheer size and unique chemistry, the Kunlun field boasts another dramatic feature: a series of massive craters that scar the seafloor. These are not impact craters from asteroids. They are the remnants of colossal hydrothermal explosions. Imagine, for a moment, the pressure building up beneath the seafloor as superheated water is trapped, unable to escape. Eventually, that pressure becomes just too much to contain, and the seafloor ruptures in a violent, explosive event. What's left behind is a huge crater, a stark reminder of the immense power simmering just below the surface. These explosive events are likely what created the deep fractures that allow seawater to reach the mantle rocks below, kickstarting the serpentinization process that produces so much hydrogen. So, the craters are not just a consequence of the hydrothermal activity, they are an integral part of what makes the Kunlun system so special. Exploring the walls of these craters is like reading the pages of a geology textbook. Scientists can see layers of rock that would normally be buried deep within the crust, providing an unprecedented look at the region's geological history. The different zones within and around the craters create a variety of microhabitats. Some organisms prefer vertical surfaces, others thrive in the sediment that collects on the floor. These systems are not permanent, they are dynamic and can change dramatically over time. By studying the aftermath of these explosions and observing how life recolonizes the newly formed terrain, scientists can learn about resilience. Now let's talk about the residents of this deep-sea metropolis. The life here is unlike anything you'd find in the sunlit world. No plants, no seaweed, just a bizarre and wonderful collection of animals that have adapted to a life of complete darkness, crushing pressure, and extreme temperatures. At the very bottom of the food chain are the chemosynthetic bacteria. These microscopic powerhouses are the true heroes of the vent ecosystem. They coat every surface, forming thick, slimy mats. Feeding on these bacterial mats are a host of smaller creatures. Scaly-foot gastropod, a strange-looking snail with a fleshy, spiky shell. Its shell is infused with iron sulfides, a literal suit of metal armor. Armies of shrimp, swarming around the vent openings, so dense they look like living clouds. These shrimp have a special sensor on their backs that can detect the faint thermal glow of the hot water. That helps them find the perfect spot, close enough to the life-giving chemicals but not so close that they get cooked. Among the most iconic vent animals are the giant tube worms. These incredible creatures can be several feet long. They have no mouth, no stomach, no gut. So how do they eat? They host bacteria inside their bodies that produce food from vent chemicals. Stepping into the kunlun-hydrothermal-field is like stepping into a time machine. It transports us back billions of years to a very different planet. Early Earth had a volatile atmosphere with very little oxygen. The oceans were a chemical soup, rich in dissolved iron and other minerals. In that ancient world, life was just beginning to take hold. The first life was probably not photosynthetic. It was chemosynthetic, like the bacteria powering Kunlun today. They are living models of where life may have started. Mineral-rich chimneys could have acted like primitive cells. Tiny pores and compartments in chimney walls could concentrate chemicals and create protected spaces for organic molecules to form. Chemical gradients, thermal gradients, and mixing could have supplied the energy for prebiotic chemistry. Those gradients are still present at Kunlun and are ideal for study. Scientists gather water samples, rock samples, and organism samples to piece together clues. They analyze organic molecules and sequence vent microbes to find ancient genes and pathways. Kunlun is a living library of our deepest ancestry. The discoveries at the kunlun-hydrothermal-field have profound implications that reach far beyond the bottom of our own ocean. They force us to think bigger, to expand our definition of what makes a planet or a moon habitable. For a long time, the search for life focused on the Goldilocks zone. But places like Kunlun show us that surface water and sunlight might not be necessary at all. Europa, Enceladus. We know these moons have vast liquid water oceans hidden beneath their frozen shells. We also have strong evidence that these oceans are in direct contact with a rocky seafloor, and that hydrothermal activity, possibly driven by serpentinization just like at Kunlun, might occur there too. These alien oceans could be home to hydrogen-rich vents, creating oases of life deep beneath the ice. By studying how life works at Kunlun, we can better design missions to search for life on these icy moons. We can learn what chemical signatures to look for in the plumes of water that erupt from Enceladus's surface. We can build instruments specifically designed to detect the byproducts of chemosynthetic life. The ecosystems at Kunlun provide a roadmap, guiding our search and helping us understand what we might find when we finally get there. The life here on Earth is teaching us how to look for life out there. Every time we send an ROV into the abyss, we are not just exploring our own planet. We are conducting vital research for the future of space exploration. The discovery of the kunlun-hydrothermal-field is a landmark achievement, a testament to human curiosity and our relentless drive to explore the unknown. Yet, for all that we've learned, we have to remember that this is just the beginning. Each dive brings new data, but it also brings a dozen new questions. What other strange creatures are lurking just beyond the reach of our lights? How does this massive system change over time? The deep ocean remains one of the last truly unexplored frontiers on our own planet. It's a staggering fact that we have better maps of the surface of Mars than we do of our own ocean floor. More than 80% of our ocean is unmapped, unobserved, unexplored. Imagine what else is down there waiting to be discovered. There could be other, even larger hydrothermal fields. There could be entirely new types of ecosystems based on chemistries we haven't even imagined yet. The potential for discovery is immense. This is why deep-sea exploration is so critically important. It's about understanding systems that govern our planet, from global climate to the very origins of life. So, as the ROVs return to the surface and the scientists begin to analyze their precious samples from Kunlun, the story is far from over.